So in this video we are going to discuss about high pass filter. So we know that the high pass filter will pass the high frequency signal that is above the cutoff frequency, and it will cut off the signal below the cutoff frequency. Okay, so it is nothing but a complement of low pass filter. Okay, and if I interchange the R and C of a low pass filter, you can able to design the high pass filter. Okay, so first let us discuss about the first order high pass filter with unity gain. Okay, so if I want to get the unity gain, we need to connect the op-amp in terms of voltage follower, right? So this is nothing but the voltage follower which is having the unity gain, right? And you have to interchange the capacitance and the and the resistor, right? So this is how the circuit is. Okay. So what is V0 now? V0 is equal to, what is VA? VA is equal to R into Vin divided by R plus 1 by SC, right? So this I can write it as SCR VA by Vin by SCR plus 1. So yes, I can write it as J omega CR, right?
And you said see you that.
So if I divide the whole term by SCR, I will get 1 divided by 1 plus 1 divided by SCR, right? So this I can write it as 1 divided by 1 plus 1 divided by J omega CR. If I multiply this term by J, I will get minus J divided by omega CR. So this I can write it as 1 minus J 2 pi F CR. Omega I can write it as 2 pi M. Okay. So we know that L is equal to 1 divided by 2 pi RC. So you substitute in this formula, you will get 1 divided by 1 minus J FL by F. Okay. So we know that V out is equal to VA. Since it is a unity gain, so I can write V out is equal to VA. So V out by VA. So what is V out by V in? That is nothing but H of, if it is in terms of S, I can write it as H of S. So H of J omega, JF. Okay, JF is equal to 1 divided by 1 minus J FL by F. So if I take the whole root, I will get 1 divided by root of 1 plus FL by F the whole square. Okay, so here the n value is 1. So n is multiplied here. Okay, so here the n value is 1. So it is a first order. Okay, that is number of pole is 1. You have 1 pole. Okay. So if we plot the equation for F and H of JF, okay, so this is constant, it is nothing but 1, okay, after that it start to fall, right, at the point called FL, okay, so this point is nothing but 0.707. Okay, so up to this point it is called as pass band. After that it is called as stop band. Okay, since it is a first order, the roll of value is minus 20 dB per decade. Okay. So now let us discuss about first order filter with variable gain. So variable gain means you have to connect in terms of non-inverting amplifier, right? So this is how it is. And you have to connect the capacitor and resistor in this manner. Okay. So at this point, now the VA, we know that from this value, we can write VA by VN, right? VA by VN is equal to 1 divided by 1 minus J FL by F, right? So VA by VN is equal to 1 divided by 1 minus J FL by F, right? So this is my FA. So what is V0? V0 is equal to 1 plus RF by R1 into VA, right? Due to it is a non-inverting amplifier, right? So what is VA now? VA is equal to V0 by one plus RF by R1. So you substitute this first equation in the second equation. Okay. Substitute 1 in 2. Okay. If I substitute 1 in 2, I will get V0 by Vn is equal to 1 plus RF by R1 divided by 1 minus J FL by F. Okay. So this is nothing but H of JF, that is equal to, here I can take this complete term as A, 1 minus J FL by F. So if I take modulus of this one, I will get A divided by 1 plus root FL by F the whole square. Okay. So if I plot the equation, suppose if they have given FL is equal to 2 kilohertz and so you substitute the value 1 divided by 2 pi RC, right? So if I substitute the 2 kilohertz and assuming the value of C is equal to 0.01 microfarad, I will get the value of R, right? So R value is 7.95 kilo ohm. So if I find the value of R and if they ask to find the gain is equal to 2. Okay, gain is equal to 2. So I can substitute 1 divided by RF by R1 is equal to 2. So that RF is equal to R1. So I can fix it as 10 kilo ohm. Okay, you can fix any value. Okay, so you can fix that value and if you plot the graph, okay. So if you plot the graph for HAF with F in terms of dB, okay. So what is 20 log of 2? 20 log of 2. 20 log of 2 is around 6.02. Okay, 6.02. So it is 6.02 initially, and at FL. So FL value is 2 kilohertz, right? So this is 2 kilohertz. At 2 kilohertz, it started to reduce. That is, this is nothing but if I subtract minus 3 dB value, I will get 3.0. Okay. So this is how it is. Okay. So this is nothing but pass band, and This is nothing but stop band.